then by all means, you can respond to only one thing. But yeah, go ahead.
Okay, well, just to narrow this down here a little bit, you said, I believe I can't write fast enough here, different clocks go at different speeds in different gravitational fields. Explain what you mean by that. I think I agree with you, but explain what that means.
So when it comes to clocks in different gravitational fields, what this means is that when you have different, let's say, for instance, I'm on Earth and we have a satellite up in orbit. The clocks are going to be running at different speeds because space-time is being, the space-time is different at these two different fields. This is one of the predictions of general relativity. So this is what I mean by clocks run slower.
Correct. Okay, so does increased gravity speed the clock up or slow it down?
It slows down time from certain observers. It depends on where you are.
So if you're breathing in the mic again, if your if your initial dot contained all the matter in the universe, wouldn't the gravity be pretty intense? Would that affect the clocks at all?
Yes, it would.
So could this 13.8 or 14.9 or 20.6 or whatever number they're using, could that be inaccurate based on that alone?
No. There are a couple of reasons for it with regard to the locations of the observers, as I mentioned, but the most important one is that the expansion happens so quickly that the mass density effectively canceled out this kind of extreme singularity very quickly. I mean, when we're talking about, the very first moments, in this Planck time, this 10 to the minus 43 seconds, this curvature is achieving near flatness at a ridiculously fast pace. So, I mean, but in any event, if it was the case that this did have an effect on the time, I don't think it would play in your favor because in a stronger gravitational field, time is moving more slowly. In which case,
well, the
universe would actually.
Yeah, I'm not trying to get it in my favor or not. I'm trying for you to understand that if indeed gravity also affects time, it may be something to consider. Okay, dark energy. You've brought that up a half a dozen times. Has this ever been, where did it come from? What is it? And what is the hard scientific evidence for even the existence of dark energy? Explain to the listening audience, what on earth is this? And is this theoretical or is this actual?
Dark energy is the name that we give to whatever is causing the acceleration of the universe.
Which is a non-answer. You don't know. You're assuming something is causing it. Therefore,
so
I don't think I agree.
Hold on. There's an uncaused cause, is what you're saying?
Well, you don't know what dark energy is.
There are a lot of things I don't know, Kent. I don't know what you had for breakfast this morning. I don't know who your mother is, but I presume you had one. I don't know how gravity works at the quantum level. I mean, what's your point? Are you trying to pin me down on something I don't know? Because I'll give you a whole list right now.
Well, no, I'm pointing out that you're relying pretty heavily on something that is not really part of science.
I'm not relying on it at all. The Big Bang Theory stands independently of dark energy. Dark energy is only used to explain the acceleration of the expansion that we're witnessing right now.
Well, and I don't think I agreed ever in any debate that the expansion of the universe is actually, that the acceleration of the expansion is actually happening. I think that may be true. I don't think it's been proven. In your mind, it's already done. It's been proven. So the universe is not only expanding, the rate of expansion is increasing.
The Nobel Committee would seem to agree with me.
Yeah, they gave Al Gore a Nobel Prize, too. I'm not sure I'm too impressed with them.
Not for science.
That's for sure. Or for common sense. Well, let's see.
Well, whatever. I'm not going to even get into that. But go ahead.
So the universe, based on the redshift and these standard candles, which may or may not be standard, you are assuming the universe is expanding, and I think it is. I think I gave a biblical explanation that came 2,600 years before anything you came up with or any of your friends came up with, that God said he stretched out the heavens, and I don't see how anything we've observed, the fact that some 600 years before Christ, observer reading Isaiah did not come up with the question about redshift is obvious. Hello, they didn't come up with a lot of questions for a long time, but it doesn't make it not true. It doesn't make your Big Bang Theory true. I think that if we just went back and looked at those 17 verses dealing with the stretching of the heavens, we could come up with the same theories and interpret the same evidence and make it match that exactly. And then when you say, when we see the scores of verses where God said he created everything in 6 days, I don't see any way other than that for it to work with all the symbiotic relationships, which is a different field of biology. But there's just, and these laws like gravity, centrifugal force, all these laws that govern our universe seem to be.
But Kent, you're being a lawyer, not a scientist. What you're trying to do right now, you're the one who is trying to force science into this Bible, this literal young Earth creationist Bible-shaped box. That is not what the scientists have done. They have made predictions about future data. Lametriere, he used Einstein's general relativity field equation. So did Alexander Friedman, by the way. We talked about him in a previous debate. And this prediction was verified by Hubble. The trouble is, you take these sort of cryptic verses. I mean, you at the very least explain the tent part to me. When it says in Isaiah that he stretched the universe and put it like a tent, what does this tent mean?
Am I on here?
And most importantly, the most important thing, as I mentioned, the central point: how do you get the cosmic microwave background radiation in a young Earth creationist universe? It's mathematically impossible. I'm convinced of this.
I muted.
Kent, you're muted. Right
yeah, there we go. Okay, there. Yeah, I'm sure you are. You're convinced of a lot of things that may or may not be true. Okay, you asked about the tent. Let's take one topic at a time. I don't know what the Isaiah verse means about God putting it in a tent. I know there are numerous verses, and you're breathing in the mic again. Somebody is. Okay. I think the Genesis 1 clearly teaches there was water above the firmament, and the firmament's clearly where the birds fly, according to verse 20. 2 Peter chapter 3 says the earth was created in the water and out of the water. And I cover for 30 minutes on my DVD number 2 about what's called the canopy theory. There used to be a crystalline canopy a few inches thick, 10 or 15 miles up. That explains the great longevity and the giant reptiles that are found fossilized. We call them dinosaurs today. Probably used to be called dragons. But certainly giant animals have lived on the earth. Giant sloth, 18 feet tall. Something was different on the planet. At some time in its history, we have fossils of centipedes, 8 feet long, and fossils of grasshoppers, 2 feet long. I think the fossil record is replete with giantism of just about every species. And this requires a greater air pressure and less radiation probably from the sun. So the Christian theory, and it is a theory, is that there was a canopy, a tent or something above the whole world, the giant greenhouse. I would pick a number wildly and say 10 miles up, there were 2 or 3 inches thick layer of super cold ice called the canopy theory, and I cover that. But again, I'm not asking for the taxpayers to pay for my view to be taught. We do this at our own expense. But I think what is beyond, Psalm 148 says waters that be, present tense, that be above the heavens. What is beyond the last star? Nobody knows. Maybe it all is in some kind of canopy or some kind of tent. So to say that we don't understand the Isaiah verse, therefore it's not true, we don't know where it all ends. Maybe everything we observe in this universe is sitting in a glass ball, a snow globe on God's dresser. You don't know that. I don't know that. We can't prove such a thing. So I think from our little, it's like Horton Hears the Who, the story, we're all Whoville, all on this little tiny speck floating around in space. Maybe we're just not as big and bad as we think we are, and maybe we're not much in the sight of the Creator, the God of the universe. So here God is telling us that he wrote a book. God is telling us that he preserved this book. And God is telling us that he came down to earth in the form of a man, Jesus Christ. And that you are, I think, directly or indirectly, are calling all of that a lie, which you're welcome to do. But I think you're in a dangerous position. Again, Pascal's wager. This is not going to affect me at all, Judgment Day, if I'm wrong. If you're right, I haven't lost a thing. I've had a wonderful life. It's amazing. And if you're wrong, you're in real serious trouble. So, okay, but that's another story. So to answer the question about the tent, I would have to say, I don't know. I don't think anybody knows, but God did say it. So maybe it takes a while for science to catch up with God's word. It certainly has all through history.
Kent, I'm sorry, but this is just a cryptic interpretation. You know, you can interpret literally anything. As I mentioned, the Muslims do it with the Quran. Other people do it with the Bhagavad Gita. Everybody takes science, as I said, and uses it to pimp their own worldview. With regard to the canopy theory, I can't get into much detail right now, but I can tell you that the friction of the caused by the variations in barometric pressures across different parts of the atmosphere would have caused it to collapse very quickly. What your canopy theory is proposing is simply not physically feasible.
It's not physically feasible for everything to be in one dot, smaller than a period on a page either.
Why? Why?
Okay, then why is the canopy theory not feasible? By what principle?
By the fact that the variance in barometric pressures would have caused friction that would have resulted in the ice canopy melting.
You wouldn't have any differential pressure, temperatures or pressures. It'd all be one even temperature. Even temperature, one even pressure. Inside of a canopy.
Kent, the atmosphere is a fluid. Its behavior is chaotic. Come on, this is basics.
What if it was compressed? Is the atmosphere inside an air compressor chamber chaotic and fluid, or is just by virtue of the pressure, is it more stable?
No. A fluid is the atmosphere is a fluid. It's comprised of particles that are behaving in you have things like turbulent flow. You have to apply chaos theory to describe the dynamics of these things. There's no way you have a uniformity of pressure, even if you try to idealize the situation. I mean, basically the only way you get that is by having a vacuum. But then good luck to all the organisms on Earth.
You need to watch the Weather Channel once in a while. When there's high pressure, there are no clouds and clear sky. When there's low pressures, when you get the turbulence. That's when you get the storms, the hurricanes,
How does that contradict what I'm saying?
Well, it's exactly opposite to what you're saying. I'm pointing out that if there were a canopy of ice above the atmosphere, squeezing our current, let's say 60 miles effective atmosphere, squeeze it down to 10 miles and cap it off with a greenhouse cap, that could be suspended by the air pressure itself, like a giant inflatable dome, or could be suspended by the magnetic field of the Earth, or maybe both.
Whoa. How is the magnetic field suspending ice? What are you talking about, Kent?
At super cold temperatures, outer space is about minus 450, 3 or 4, I don't know, depending on your location, I'm sure, but Fahrenheit, or 2 degrees, 3 degrees Kelvin, or minus 172, whatever it is, 171 centigrade, whatever scale you want to use. I think everybody would agree that outer space is real chilly, close to absolute zero. So
I'm not disputing that the canopy would have been ice if it had existed. What I'm disputing is that the magnetic field is even remotely capable, even in principle, of holding up this kind of structure you're describing. I mean, what kind of physics are you coming up with?
As ice gets colder and colder, it changes its crystalline structure. Under pressure, glacial ice turns to firn, F-I-R-N, and it will flow like a plastic. Under extremely low temperatures, ice starts to become laminated. It becomes hydrogen layers, oxygen layers, hydrogen layers, rather than the six-sided crystal of typical ice, that snowflake type crystal that changes crystalline structure. And there's a large article on Carl Baugh's website about this. I can't think of the name of his website now, creationevidence.org, about the crystalline structure of ice changing at extremely low temperatures. So if there were a crystalline canopy above the Earth, and that's what the Jews have always taught. Josephus taught that. He was a Roman, well, he worked for the Roman army, but he was a Jew, captured slave. He said there was a crystalline canopy above the atmosphere. And this is in the first chapter, Josephus chapter 1. So I think this has been historically always believed, that there was a crystalline canopy above the atmosphere, which nobody could have possibly known. You're breathing in the mic again. But they could not have seen such a thing or known such a thing. But if you had a crystalline canopy suspended by either air pressure or magnetic field, because super cold ice does become magnetic, and it levitates like the Japanese trains. They float them off the tracks with magnetic levitation. I don't know, it's gone. Okay, just be theoretical. But if there were a canopy squeezing the current 60 miles of air down to, say, 10 miles, you would have an increase of pressure at the surface of maybe 15, 20%. Just a guess. That would cause all kinds of interesting effects. Everything could breathe easier. Things could grow larger. They would probably be 30% oxygen instead of 21%. And that's what the amber air bubbles trapped in amber indicate that the air used to contain 32 to 35% oxygen, which is absolutely optimum for life. You get more than that, you start to get problems, but up to 35% is wonderful. Ask any people working in a hospital or hyperbaric chamber. It's amazing to breathe high pressure air.
Have you ever heard of Wolfgang Pauli?
I have. I don't know anything about it, but yes, I've heard the name.
Well, he had an expression when one of his students would ask him something about physics that made absolutely no sense, that was completely bonkers and that had no correspondence even to a coherent thought. He would look at them sadly and he would say, "That's not even wrong." Kent, with all due respect, what you just told me right now is not even wrong.
Neither is your idea of all the temperature being in a dot smaller than a period. That is dumb. Capital
On what
D,
principle?
dumb.
On what principle?
Common sense. Where's all this temperature coming
Kent,
from, and how
screw
you
your common sense. Tell me what physics prevented from happening.
What physics prevents a canopy from being above the atmosphere?
When it comes to being above the atmosphere, there are a zillion things. I can't even get into them. I want to get back to the one that I was actually addressing with regard to the differentials in barometric pressure at different points. I'm telling you, even if you can get this thing to float, I'm not even magnetic field lines. Jesus. Even if this thing were viable in the manner that you're trying to describe, the thing would not last. These differences in pressure are going to cause the differences in the turbulent flows in different parts of the atmosphere are inevitably going to cause the entire thing to collapse, and it's going to happen very quickly. I mean, well, the friction is going to change the temperature. The temperature is going to crack it and melt it. There's going to be thermal expansion. It's ridiculous. Come on.
Watch the Weather Channel. You don't get the turbulent flows until there's low pressure. I tried to explain to you. With high pressure, this doesn't happen. Ask anybody with a hyperbaric chamber. There's probably one in your area. Most hospitals have one now. You change the dynamics by increasing the pressure. Some of the comments are coming up about taking questions, and I've got a 9 o'clock appointment in 12 minutes here. So
yeah, let's just get to the questions.
Well, one of the questions that I think we need to actually redress is that when we're talking about the recombination period, Kent, and the fact that the Big Bang predicted the exact temperature of what the CMB should be around 5K. It actually ended up being about 2.725K. That is a novel prediction. So the question I have to ask is since that was a novel prediction that the Big Bang model did in fact predict prior to the discovery of it, why didn't creation science predict that? And how does that not help confirm that the Big Bang model is a predictive model that works?
Well, this goes back to King Crocoduck Sinus's lawyer model. Any lawyer will tell you two people can look at the same predictions or the same evidence and come with all kinds of different theories.
Whoa. Predictions? No, Kent. Evidence.
Okay.
Not predictions.
We look at the same
they're
evidence.
Looking at the evidence.
Okay.
Hold on. They're looking at the evidence after it materializes. The Big Bang Theory predicted the cosmic microwave background radiation before it was ever dreamed about.
Okay, suppose in the movie
you have to explain why why was the Big Bang Theory capable of doing this? Why did it succeed in this?
That doesn't make it true. Suppose in the movie The Green Mile they predicted the girls would be found dead with a black man. Oh, and yes, look at this. They're found dead with a black man. John Coffey's holding the dead girls. John Coffey didn't kill them.
Is that how the movie went, Kent? Did they predict it beforehand, or did they find it afterward and then interpret it?
You didn't listen. I said, suppose they had predicted it.
Suppose they had, then it would be a completely different story.
Oh, then it would be true that John Coffey killed him.
Yeah, it's a different story at this point. It's a different story at this point. If, for example, let's say that somebody got a tip-off that John Coffey was planning on murdering these two girls, and then they had the time and the date and the exact manner in which it would happen, and then they find John Coffey, and it matches all of the associated predictions, then yes, the evidence overwhelmingly supports his conviction in that case. But that's not what happened in the movie.
Well, okay, suppose they did predict, and suppose they had a letter from John Coffey, I'm going to kill these girls. That still wouldn't prove he did it. Any freshman law student could take that argument apart. Come on.
But Kent,
Wait, not the letter. Lawyer, Kent, hold on. We're not talking. I didn't say anything about a letter. I agree that just because of a person said that he did something doesn't mean that he actually did it. There has to be physical evidence, and I gave you an example of how this physical evidence could potentially materialize and result in his conviction.
Well, we've got questions waiting for us here, but I think go back and re-listen to this and try to understand it. It is still possible for him not to have done it, even if it was predicted ahead of time that he'd be found with a black man. And back in the 30s and 40s, they blamed everything on the black people, a lot of things. So
okay, I'm not going to play these rhetorical games. The fact of the matter is, if you can make an accurate prediction using the physical evidence, the conviction is fully warranted. Black, white, green, purple doesn't matter. But
that is ridiculous. That statement you just made is ludicrous. It doesn't prove anything. If they predicted things, there still could be multiple other options. But let's take the questions here.
Kent, do you agree, though, that the model did successfully make a very novel prediction that creation science did not make? Do you acknowledge that?
I don't know that to be true. I don't know what all predictions have been made by who, and what if it turns out that, what if it turns out
the prediction was
okay, we've been through all this. What if it turns out that one of those guys who made this prediction was a creationist, like the guy who invented the MRI machine? Whoa, he's a creationist.
It makes no difference.
It makes
what
no
difference does it make? That would be an ad hominem. So what's your point?
He still used physics to do it. He still used conventional physics to make that prediction. Did he not? Okay. We'll go on to the next question. Next question is by the Living Dinosaur. Many of you guys may know him. He's been around for a long time. He is back. Welcome back, Living Dinosaur. But this is not really specifically to this particular discussion with physics, but I think it's a relative question. He says, please ask Kent, what's his justification for calling evolution a stupid religion? If you really believe it's religion, then why does you feel that it's acceptable to insult it? Does that mean that you're okay with non-Christians insulting your religion? After all, wouldn't that make you a hypocrite if you think that it's okay to insult a religion?
Oh, you want to just search the internet for Kent Hovind. You want to see people insulting my religion? Sure, it happens all the time. I can handle. I got thick skin. Doesn't bother me at all. And yes, evolution, depending on which definition you use for the word, and I carefully divide it up into 6 categories, which it has to be divided to look at it. 5 of them are purely religious. You have to believe in it, which is fine. You can believe in the Big Bang. I don't care. And you can interpret the evidence to mean that to take it as a scientific fact or part of your dogma. Every religion looks at things and says, aha, see, this proves our religion is true. I mean, all of them do that.
Another example of how a creationist steals from a scientist. Listen, Kent, this evolution 6 different definitions thing, we went over this last time. I told you, this is nonsense. Evolution can be used to describe literally any phenomena that changes with respect to time. I gave you an example of how every undergraduate in physics has a textbook by Griffiths called Introduction to Quantum Mechanics, and how it has a section in it called the time evolution of the Schrodinger equation. Tell me, Kent, how does the time evolution of a Schrodinger equation fit into your 6 different types of evolution? Is this the 7th kind? What if I throw in new kinds? I mean, tell me, how does this come in?
Well, we're supposed to be taking audience. We're taking audience questions here, but the evolution means unrolling. The word literally means unrolling. It can be used for all sorts of things. The evolution of the automobile from the Model T to the Lincoln Continental. You can use that word, but I give it in biological, in the textbook. I show right straight from the textbooks that they teach the 6 different meanings of evolution: cosmic, chemical, organic, which you have to get into stellar evolution. Nobody sees this. They believe it. We've never seen life come from non-living material, but that's organic evolution. It's in all Google Berkeley. Just Google organic evolution.
Google evolution of the Schrodinger equation. Google evolution of the birth control pill. Google yeah. So the word means okay. So there's nothing special about these specific types of evolution. You specifically select these types of evolution, and you conflate them all in order to make them guilty by association. Apparently.
So you said we went over this, and therefore, because you did not agree with something I said, therefore I'm wrong. You're right. Let's go back to the audience questions here.
All right. Next question. Okay.
Yeah, go ahead.
Okay. Next question is from Helena Handbasket for KC, actually. It is not extremely unusual for lay people to think of the Big Bang as an explosion. Can you explain in simple language why this is not an accurate view, what a better view is, and why it matters? And then Ken say whether he rejects or accepts your explanation.
Well, explosions typically refer to oxidation reactions, a sudden release. It's typically a chemical reaction that this is referring to. rather than what's actually going on with the Big Bang Theory, where you have the expansion of the universe. Now, of course, the energy is expanding with it, and in principle, there is this superficial resemblance to an explosion. But in the same vein, I could say that flatulence is the release of energy, and that this also constitutes an explosion, which I suppose some could argue that it is. But, when we think explosion, we don't typically mean flatulence. So, yeah, anyway, the distinction matters because you frequently have the straw man of, an explosion is not going to produce a universe. It's like, okay, well, fine. If you're going to blow up a bomb and you expect a universe to emerge, you are an idiot. And if you think that other people expect it, then you are either committing a straw man or you're an idiot. This is not what's being described by the Big Bang Theory. You have the expansion of the universe. Energy is moving outward. It's becoming less dense. It's becoming more cool. And you have the emergence of structures as a result of this cooling. So that's sort of the long and short of it.
Well, I would agree. The word explosion can mean a number of things. The explosion of the population, the explosion of the number of cars on the street. Sure, the word, again, you got to define your terms. But the Big Bang is, I show in my seminar dozens of textbooks where they do teach it was an explosion of a dot smaller than a period on a page. And so if you want, I'd say a hand grenade is actually the expansion of the metal fragments. It's not actually an explosion. It's the expansion of the metal fragments. Come on, it's talking about an explosion. And nobody's ever seen any expansion of materials reaccumulate. Why would the fragments of this explosion or this expansion, Big Bang, why would they accumulate into clumps like stars and galaxies? Why isn't it all just particles evenly distributed throughout all of visible space? How do we have clumps of any matter anywhere?
Gravity! Come on, Ken, this is basic physics. Gravity!
I understand gravity, I think, is probably as well as anybody. Yes, and I'm using it right now, actually, sitting on a chair. So, yes, gravity. So these particles that are flying away from each other, assuming in a radial direction from this expansion, they're going to reaccumulate. The further you go away, the farther apart they get. But they're going to somehow find each other and pull each other together, even though they're continually expanding, getting further apart. I think it's common sense 101 to say that's not logical. The fragments should be spread everywhere. So the question was...
Go again with the common sense. Kent, they did this experiment in space. They went into the International Space Station. They took these particles, I think it was sand or dust or something along the lines of along those lines, and they shook them around, and they saw that they spontaneously accumulated, even though they were going in every direction.
Well, yeah, out in space, I agree. That's where Uranus came from. The dumping the urine overboard on the early space flights. It followed the space capsule because that's the strongest, the biggest attraction and the biggest show in town was the thing right there. So yeah, that's
okay, but the point is, even if things are moving apart in a vacuum, the gravity is going to pull them together.
Casey, let me ask you as a follow-up to this. Would you say, though, an explosion is typically something increasing in a unit volume of space, while the Big Bang was the volume of space that was expanding itself? That's why it actually is not an explosion. But for the laypersons, for an analogy, they call it an explosion, but you'll never see that terminology used in actual scientific literature.
Yeah, it's a good point. If you think of conventional explosions in terms of somebody detonating TNT, you have the motion of objects through space, whereas with the Big Bang, what you actually have are objects embedded in their positions in space. Of course, they can move around, but the expansion of the universe is not causing it to move with respect to the space. The expansion of the universe is causing them to move away with respect to each other. And for an analogy for how you can have this take place, you can imagine a cake with raisins embedded inside of it in 3 dimensions. You put the raisins in the dough, and then you put the dough inside of the oven, and you heat it up. And as you heat it up, the dough begins to expand, and it carries the raisins with it. Now, the raisins are not moving with respect to the dough. They're moving with respect to each other, but that's because the dough is expanding. The raisins themselves are not moving with respect to the dough. So that would be the difference. This would be the analogy of the Big Bang. Whereas the analogy of a conventional explosion, the raisin is inside of there, and then it suddenly pops and it moves to other parts of the cake. So that's a significant difference.
We got about 5 minutes left, so let's go ahead and do your closing statements. Normally, Kent, do you go last? Do you want to go first this time?
It does not matter. Let the young fellow just do whatever he wants. What would you like?
You go ahead, Kent.
Well, I believe, as I started off saying, that the Bible is literally true. There is plenty of evidence the universe cannot possibly be billions of years old. Looking at the Big Bang or the red shift or the cosmic background radiation can easily be explained by exactly what the Bible taught, even though it may be that an evolutionist or an atheist even discovered this cosmic background radiation. Oh, well, I'm sorry that some creationist or some Christian or some Bible believer didn't discover it first. It may be true. Still doesn't have anything to do with proving evolution is true. So I think the position for Pascal's wager that my position is perfectly safe and fine. Either way, I win. One way, you lose. And I think that you have to wonder if we are indeed nothing but particles that came from an explosion or an expansion of the universe. Your mind then would be nothing but a bunch of material from this space dust. And I'm not sure how you can trust your own thoughts or your reasoning processes or conclusions you come to. It may have a chemical in there backwards. So you're trusting your own logic and intuition, which intuitively is untrustworthy because it's nothing but random chemicals formed by chance over billions of years. So I've seen nothing tonight or in any of our discussions or debates to make me want to reject the clear teaching of God's word that he did it in 6 days. And it's only, well, I say only is a bad word. 6,000 is a long time. 6,000 years ago is a long time, but that's what the Bible clearly teaches. And I think that everything we see in space or on the planet or in the planet can be explained by the clear teachings of God's word. So I think I'll stick with my Bible. And Jesus said the creation of Adam was the beginning. I believe he was right. And Jesus clearly said, and all through the Bible, we see there's going to be a judgment day one day. Every word we've ever spoken is going to be brought into account. There's something innate in humans to want to see the bad guy get it in the movies. You know, the guy who's going around killing people, you say, man, somebody ought to stop him. I think that just the fact that that's innate in us is indication that there's something of a moral conscience that had to be embedded by the Creator, because he is going to settle all scores. The bad guy is going to get it. It's according to the Bible. There will be a judgment day. There will be a test at the end of this. And all this whole conversation will be replayed, every word. Only this time, God himself will be the judge and answer all the questions if you really want one. So yeah, I'll stick with my Bible. I think it's literally true, and I think it leads to a wonderful society if everybody tries to follow that. Certainly makes you better fathers, better husbands, better brothers. I think I think the evolution theory that we're just random particles is going to lead to chaos in society. If everybody believed that, I think it would lead to absolute chaos, but that's a different topic of the moral implications of what you believe versus what I believe. But I think scientifically, everything can be explained exactly like I showed you from God said 17 times he stretched out the universe. That's what he said. Okay?
All right, thank you, Kent. Go ahead, KC.
Okay. Well, I'm just going to really briefly address this chaos in societies where people accept evolutionary theory and science. I mean, this is, with all due respect, this is the height of intellectual cowardice. Look at the people on my screen and tell me that it's conceivable that a person can hide behind their Bible and say that the scientific matter has something to do with morality. This conflation it's distasteful. Chaos in societies which accept scientific theories. You know, I'm sorry, Kent, but you know, if you compare, for instance, Japan to Saudi Arabia, and compare the people who accept evolutionary theory in one, you know, anywhere in the Middle East, very religious places, you're going to, and compare it to, you know, these other societies. You know, I mentioned Japan, and I could mention the United Kingdom for a time. I could mention any number of them. The point is, we're not, your prediction that you see more chaos in a society that accepts the science, it's simply not true. But the main point I want to make is actually on this part right here. You came up with a straw man just now about how it's supposedly because an evolutionist discovered the cosmic microwave background radiation, suddenly it's true. This was not the argument at all. Look at the first part of this. The scientific theory's strength relies on its predictive power. How accurately does it make novel, testable predictions about future data? And I think that you and I have both come to agree, even though you don't think that this makes it a good model, even though, you know, it kind of does. the fact that this was predicted exclusively by the Big Bang Theory, and that this was done exquisitely over the course of several decades, lends more strength to the Big Bang Theory than the young Earth creationist model has ever had. So I'm sorry, but you simply don't have a leg to stand on. Compare what I've brought to the table in terms of, it's not just the interpretation of evidence, it's the actual prediction of data that we have at our disposal. All right, we're not looking at the same evidence and interpreting it differently. We predicted what evidence we should be interpreting in the first place. Okay, this is not at all a level playing field. So that's all I have to say about that.
Thanks, KC. Well, we're going to wrap this up. I want to thank both our debaters tonight, King Crocoduck and Kent Hovind, and to all of you who watched this debate. I also want to shout out to Paula Gia, who produced a magnificent trailer to promote this debate, as well to Godless Cranium, who also helped promote this event on his channel. If you haven't subscribed to either of their channels, please do so, as they both have extremely wonderful content, very much worth watching, and the links to their channels are below. So please go subscribe to them, as well as subscribe to King Crocoduck and Kent Hovind on Kent Hovind Official. If you'd like to be a part of these debates and join in the conversation, the link to join the Great Debate community is also in the links below. And there will be an after show in about 20 minutes or so on this channel, and all are welcome to join. And we will see you then. Thanks, everybody, for watching.